Hi. So today I'm going to talk about the time dimension, and as you know by now that time is a very important and a unique dimension, and most of our analysis has a time component attached to it. And if you look at the definition of a data warehouse, so it says time invariant, right? So there are two aspects to that. One is that it talks about historical data, and second is it is about that all analysis that we do is with respect to time dimension. So time dimension is very important. So in today's lecture we are going to look at different aspects of the time dimension. So time is a unique and powerful. Let me just close this. So time is a unique and powerful dimension in every data mart and enterprise data warehouse. And time dimension is very special and should be treated differently from other dimensions. And example of a star schema, say this we have been looking at for quite some time now. Fact table records daily orders received by a manufacturing company. Time dimension designates calendar days, right? So basically about this. So if we have a daily thing, so I'm talking about days, right? So it can go up to any granularity. So the main issues in talking about time is the granularity aspect. At what granularity you are designing your data warehouse, and accordingly the time dimension would be designed. And it is special in the sense that you do not get this dimension ready-made from the operational system. So in operational system, time is just wherever there's a talk about time, it is just an attribute, right? So like unlike other dimensions like products and customers, so there is typically a master table that is there, or a store master, right, or a location master. But for time, you will not find a time master. So there is no source as such of a time dimension. So let us now look into some more details. So there are 2-3 things. So first question that we want to address is, do we actually need a time dimension? So there are some facts, that is frequently asked questions about time dimension. Why can't I just leave out the time dimension? So here, so there are a couple of things which are very important, which I want to highlight. So time dimension serves as the source of constraints and as the source of report row headers. So anything that you do with the dimension tables, whether any kind of dimension, so it serves as a constraint. So you enter the fact table through the dimension table. So you first constrain the dimension tables and then you enter the fact table. And as also as a source of report row headers. So if you want to put any headers on the reports that you are generating, so you typically use the dimension table attributes that are there. And a data mart or a data warehouse is only as good as its dimension table. So if you have put a lot of relevant attributes in the dimension tables, so the more relevant it becomes, or more important, or more I can say more important it becomes. I would not say important, but it would be like it becomes like it facilitates more analysis, right? So varied kind of analysis you can do using the attributes in the dimension. And if you look at SQL, right, so it provides some very minimal assistance in navigating dates. So if you have worked with the date timestamp, so you would know this. So there are lots of functions, but these are not very intuitive to use, right? And many a times you get stuck, like how to work around this data type. So, and another very important aspect in this whole thing is that SQL or the RDBMS that you are storing your data in has no information about your corporate calendar, your fiscal periods or your seasons, right? So every vertical has its own seasons, high seasons, low seasons, right? And so the corporate calendar, like for example, if you look at a university like BITS, right, so it has its own calendar, academic calendar. So no SQL or no database would have information about that. So where do you keep all this information? So this is one question. So we are basically moving, we are having a discussion on whether we should have a time dimension or not, right? So yeah, so this discussion basically tells us that you should have a time dimension, because a lot of analysis that you want to do with respect to time, you cannot always be going back to the SQL supported features of the data type to handle or to answer your queries. So you need to have a time dimension. Now the second question, the second fact about this is, if I have to have a time dimension, where do I get it? So it is, as I said in the beginning of this lecture, that I do not get this time dimension like I get the other dimensions from the production systems or from the operational systems. So what we have to do is we have to build it in a spreadsheet. So that is very important. So some data marts additionally track time of day to the nearest minute or even to nearest second. For these cases, separate the time of day measure as a numeric fact. It should not be combined into one key with calendar day dimension, because then this would become a very, very large dimension table. So because say if I look at the seconds granularity, so there are 60 seconds in a minute, and there are 60 minutes in a day, and there are 24 hours, and like this. So this is for a single day, one day, right? So that makes it very the dimension becomes very, very huge. So we don't want to do that. For these cases, we separate the time of day measure out as a separate numeric fact. So we just take it out, right, time of day, or the timestamp as we call it, into a separate numeric fact, right? And it should not be combined with just one key that you have, because then you will have so many keys for the time, right? So granularity, as I said, is important. And another thing that the time dimension has is that it has got multiple hierarchies present in this. So as I say if you look at day, so I'll represent it by D, then I can go to week, then I can go to year, right? Then I can go to day to month, month to quarter, and quarter to year. So there are multiple hierarchies. Now these weeks do not add up to months, or they do not add up to quarter, right? So these are incompatible roll-ups like weeks and months. So weeks and months cannot be rolled up, right, into, like, weeks cannot be rolled up into months. And separate fact table dimensions in weeks and months should be avoided at all costs. So because then it would always give you confusing state, right? And uniform time roll-up should be used in all the separate data marts. So same kind of roll-up should be used in different data marts, so that when you look at the data warehouse, you get a uniform picture. And it is always recommended that you work on the daily granularity wherever it is possible, right? Sometimes it may turn out to be very granular for you, very fine granularity for you. Sometimes it may turn out to be very coarse, but anything that you record the daily granularity, it rolls up to every possible calendar. So this I told you. So if I start with day, I can work with months, I can work with weeks, I can work with months I can work with quarters, and quarters I can work with for years. So in here it is, from weeks I can go up to year. So something like that. Okay, so daily granularity that way is considered good. And so be careful about aggregating non-additive facts with respect to time. So I think we have talked about semi-additive and non-additive facts earlier. So if I look at account balance, right, as a fact, so it is not additive with respect to the time or day. So if I have an account balance of 500 today and 600 tomorrow, so it doesn't mean that I have a balance of 1100 over 2 days, right? So that is not correct. Inventory levels and account balances are example, and we need average over time. So SQL average is not the kind of average that you are looking for. It does not average over time. Moving average is now being supported in some RDBMSs, and there is a kind of a concept in SQL that has been introduced recently, that is called as window. Not recently, but yeah, in keeping in mind the data warehouse requirements. So window. So you can form a window of any size around a particular time period. Like if I say select today, so I can add the previous 2 days or the previous 2 days and the following 2 days. So any kind of window I can create with respect to a given reference. So this window operator is very, very useful, and I'll be talking about this window, this SQL extensions for data warehousing in one of the later modules in detail. And the time dimension looks like this. So this is a typical time dimension. So you can see time key. So that is the first one that you have. I'll clear this first. Yeah. So time key, this is the surrogate key that you have. Then you have day of week. So I'll also be talking about one more aspect of redundancy while talking about the time dimension, although it is not there explicitly in the slides, but I would want to talk about it. So this is like day number in month. So this is say, so time key is say 20, okay. Day of week is say Monday, okay. And day number in month is say 6. Day number overall, so this is right from the start of the data warehouse. So suppose this is 372. Month, whatever is the month, say it is May. So I'm writing down example values. Month number overall, it could be 20 or 13. Say I'm just quarter. I'll write down the quarter. So it is quarter 1. Fiscal period, it may not match with the quarter, right? A calendar quarter. Season, say summer, or season, yes or no. Sometimes it is not the season, the weather. So it is yes or no. So whether it is the season for selling this particular product. Holiday flag, yes or no. So suppose it is not a holiday. Weekday flag, yes, it is a weekday, right? And last month in day in month flag, say no, because last month in day would have either 30 or 31st. So this is how I populate my dimension table, right? So these are the things that I put. Now you would say that the date dimension that you have, right? Okay. Oh, sorry. So not date dimension, date data type that you have, right? So if I write the date, say today's date is say 28/5/15. So all the information that is there that I have written explicitly in these attributes can be extracted from here, right? So I can extract all this information that I'm talking about from this date data. Most of them I can extract from here. So why I'm putting them explicitly or redundantly in my system? Okay, so the answer to this is that date data type is typically stored as a string. It's a 8-byte string, and it is stored as a string. So any kind of information that you want to extract, say what is the month, so you have to do string operations or string manipulation. So as you know, string operations are typically very expensive, right? So to avoid all these string operations, I store whatever information I need explicitly in my database, right, or in my time dimension, right? So that's what I'm talking about, redundantly storing this information. I'm calling it redundancy because this information can be derived, right? And like holiday flag. So this flag, this part will not be available anywhere, right? So you will not get this information anywhere, right? Season information you will not get, so because it varies from domain to domain, right? Your fiscal and quarters, fiscal period, quarter, all those things can be different for different organizations and for different businesses, right? So that's why it becomes important that you have a time dimension and put as many relevant attributes as you can in this. So I mean, this is not the end. I mean, there are so many other attributes I can add. So I can always add year, right? I can always add, say if I'm talking about a university, I can add something called as academic year. So we typically talk in terms of 2014, 15, like this, right? So I can do a lot of things with the time dimension. And once I have put all the relevant attributes in here, I can do lots of analysis. So this weekday flag is also very important. And sometimes we also keep not just weekday or weekend, because I want to do some analysis whether we are doing more business on weekdays or on weekends, right? And also I can have some special events. Say recently this IPL is going on, right? Or it just got over. So if there's an IPL match in the city, right, in a particular location, right? So I want to record whether there's a special event or not, yes or no. So because during this, a lot of tourists would come into the city to watch the match, so probably your sales would go up, right? And now towards the end of this lecture, I would want to show you exact time dimension, how it looks. Excuse me. Right, so this is how it looks like. I'll clear the annotations. Okay, so you can see here, so first column is the day, okay, then I'm putting it as weekday, which day of the month it is. I can also put a weekend flag here, right, yes or no. Year I'm putting explicitly from extracting from here and putting it here. Calendar quarter, so you can see this is the fourth quarter. This is October, right? So this is the fourth quarter in terms of calendar. Calendar month, it is October. Calendar week, it is 41st week in the year, right? Calendar day, it is this much. Then month is October, right? So calendar month. So you can see all these kinds of information, because I may have to generate some report in which I want to keep October, right? I want to write October. Day of month, so days are mentioned here. And financial year, it is 2009, 2010, so I'm putting 2000. This is how I store it, okay. And financial quarter is second, because I mean, this could be the situation in this particular case, right? So I can add lots of fields which I want, and I can constrain my time dimension in any way I like. And for that, I don't have to do too much of computation or too much of filtering, because of these explicit fields that I have put in place, right? So that's how the time dimension looks like. And you can see, so one thing that you can try doing is that you take a daily granularity time dimension and build it in a spreadsheet. Try building it in a spreadsheet kind of an environment, okay. So that would give you a lot of idea about how this is made. And calendar days, and there is like days since epoch, day number, so there is a typical field which is there, day number since epoch. Epoch means the start of the warehouse, right? So all these things you can put in here and do whatever analysis you want from this time dimension. So I can conclude this session or lecture by saying that time dimension is one of the most important dimensions, and it is unique, and you don't find it in the production system, so you have to build it on your own. And putting as many attributes as you can in this table, relevant attributes, and don't worry about redundancy. Okay, so all these things you can incorporate in the time dimension, and it helps you do many different kinds of analysis. So with this, I end this lecture. Next topic would be on, if you go by the handout, next topic would be on conformed dimensions and facts. So there again, time dimension would come into picture. Okay, thank you.